In this lesson, we're going to do a very brief overview of how light works. And, this is a huge field of study, light, and kind of the physics that goes along with it. But we're going to just focus on the aspects that matter for being able to see, and in turn for computers to be able to see as well. So we're going to jump into this. So the first thing to know is that light is the common name for electromagnetic radiation. So that's something that's kind of just useful to know, is that when we're in physics, we talk about it as electromagnetic radiation, because typically when we're used to thinking about light, we're used to thinking about visible light, the stuff that our eyes can see. But more broadly than that, light or electromagnetic radiation is a wave that travels through the electromagnetic field. And for this class, you can think of as a wave as just a vibration. So you can imagine this thing, the electromagnetic field. You don't need to really worry what it is, but you can just imagine that vibrating, and then if you send a vibration through it, kind of like if you shake one end of it and it vibrates through, that's all that light is. The important thing with this is knowing that because it's traveling through the electromagnetic field, it doesn't need any sort of physical medium. And I know I'm going through this a little bit backwards, but it doesn't require a physical medium like air or water to travel. It can travel through a vacuum. So even if we would say that nothing is there, light can still travel through that space. So light travels through the electromagnetic field, which means it can travel through a vacuum. It doesn't require a physical medium. So while it is traveling, it's going to travel in straight lines. So it's not going to bend under normal circumstances, it's just going to travel straight until a surface, until it hits a surface where they can either reflect or absorb. So when light hits something, it either reflects off of it or absorbs it. And technically all objects both absorb and reflect light. And we'll talk about that in a second. But any object that's being hit with light, it's going to absorb some of the light and reflect some of the light. Now, things that we traditionally think as reflective will reflect more light and absorb only a little, and things that we think of as not very reflective will absorb most of the light and reflect very little. But every object kind of in our daily, everyday lives here on Earth, all objects do both. They absorb some, they reflect some. If you want to talk more about the edge cases of things that don't necessarily absorb or don't necessarily reflect, chat with me kind of individually about that. So there's two types of reflection that we're going to look at. First, with a traditional reflective surface that we think of, all the light is reflected in an organized way. So that's the key word here. Organized is the reflection. So if you're thinking about a mirror, what that means, imagine this is a mirror, all the light that comes in like this gets reflected off in a nice organized fashion. So things that you think of as reflective, like you can see yourself in them or you can see the light bouncing off, that's because it's bouncing off in this nice organized way. So all the light goes in the same direction and it bounces off in the same direction. So that's an example, is a mirror. The second type of reflection that we're going to deal with is a non-reflective surface. And in this case, it reflects light in a disorganized way, or in other words, we say that it scatters. light. It's still reflecting light, but it's scattering it. And an example here might be, say, an apple. So we know that the apple is reflecting light because we can see it, right? If it wasn't reflecting light, you wouldn't be able to see it because, you'd have no way of knowing it's there. But what happens with, say, the apple is you have the light come in nice and organized. Say these 3 beams are coming in. But when they hit that apple, they get bounced off, say, like that, and like that. So in other words, the light goes off in all random directions. So that's why you can't see yourself in it, because the light that, say, was bouncing off of you, or the light coming from the sun, or the candle or whatever, shoots off in all random directions. And so it's still reflecting light. We can still see it. Anything that you can see the color of, it's reflecting light, or it's generating its own light, but most objects just reflect light. But what they're doing is they're scattering the light, which is why we don't typically call it reflective in common everyday English. And so if we want to make an image is formed whenever scattered light is focused or concentrated back to a single point. And so for example here, if I have a candle, so imagine I've got a candle here that's lit. And then I've got a lens here. What'll happen is, say a bunch of light is going to get scattered off of this candle top. Well, some of the light will go up here and miss the lens. Some of it will go right here. Some of it will go right here. Some of it will go here. But where it's hitting the lens, if everything and all the conditions are right, what will happen is that light will come back together on the other side of the lens. In other words, a bunch of light from the top of the candle appears back together over here. And the same thing at the bottom. Let me grab a different color pen here. At the bottom, imagine we have these blue rays coming off. And they'll get focused back down here. And so what we end up having is the bottom of the candle kind of refocuses over here. The top of the candle also refocuses there. And effectively on the other side, we get an image of the candle forming, because all the light that was leaving the candle comes back together, and actually it keeps continuing along its way. And so as far as our eyes are concerned, it looks like the candle is located over here as well as over here. So that's getting a little bit into the technical physics of it, but all you need to care about is that if we take scattered light and we focus it back to a single point, then we can create an image.